Okay, this is chapter 7.3, multiplying and dividing rational expressions. So the essential question is, how can you determine the excluded values in a product or quotient of two rational expressions? What you will learn in this chapter is how to simplify rational expressions, multiply rational expressions, and divide rational expressions. So let's take a look. All right, core concept, simplifying rational expressions. So let A, B, and C be expressions with B not equal to 0 because it's in the denominator, and C not equal to 0 because there's a C also in the denominator. The property states that if A times C over B times C equals A over B, if you are multiplying, then the C's will cancel. So divide out common factor C. C divided by C is 1. A times 1 over B times 1 equals AB over B. But in the bottom here, we have 15 over 65. And that equals 3 times 5. 3 times 5 is 15. 13 times 5 is 65. Since this is multiplication, we can cancel the 5s. And that reduces 15/65 to 3 over 13. In this expression, right here, it's 4 times the quantity x plus 3 divided by x plus 3 times x plus 3, and that would have been x squared plus 6x plus 9 factored. And then you can cancel out the x plus 3's, but that leaves one of them, and that would result in 4 over x plus 3. So they aren't saying anything about what these are, but when it doesn't cancel, that's an asymptote. And when it does cancel, it's a whole. And we'll get into that a little deeper after this. Okay, so simplifying rational expressions is really not that difficult because we've already done it, really. And what I mean by that is we have factored quadratics before. So this is x squared minus 4x minus 12 divided by x squared minus 4. Keep in mind, I think everybody's aware, but sometimes we forget. These x squareds, since there's a minus sign here, it's not multiplication. You cannot cancel the x squareds. Okay, so just be careful and don't make that mistake. Those have to be factored first. So if I simplify these, x squared minus 4x minus 12 would become x times something, and x over here, it's a zero product property, and factors of 12 that add up to 4. And so I'm just going to do this 12 one time. 12 is 1 times 12, or 2 times 6, or 3 times 4. Okay, it's negative, and the middle term's negative, so the bigger number has to be negative. So it's 1 times negative 12, 2 times negative 6, or 3 times negative 4, which is what would go here. So which is it? Well, we need a negative 4 sum, and that's this right here. So it's going to be x plus 2 and x minus 6 is what this factors out to be. And then the x squared minus 4. Don't forget, this is a perfect square. This is a perfect square. It's called the difference of squares. So what you do is you just do the same thing here. And the difference of squares is plus or minus the square root. So square root of x squared is x. Square root of 4 is 2. So if I FOIL this, I get x times x is x squared. X times negative 2 is negative 2x. But then the middle term cancels it because that's positive 2x. So minus 2x plus 2x cancels. And a positive times a negative is negative. 2 times 2 is 4. Okay, so there's our two factors. So what I'm going to do is rewrite this with our factors. So this is going to become x plus 2, x minus 6 divided by x plus 2, x minus 2. The x plus 2 divided by x plus 2, since these are being multiplied, cancel. And my outcome is x minus 6 over x minus 2. So this is the simplified rational expression that came from our original. Okay, so that's how you do these, and now you should be able to do problem numbers 3 and 4 in your exercises. One thing I didn't mention though is, and I need to, let me just erase this edge here. You should also say x cannot equal 2. Okay, make sure you explain what the denominator cannot turn out to be. So don't forget to restrict your domain. Okay, x cannot be 2 because 2 minus 2 is 0. Okay, so now that's the answer. Okay, so now we have a core concept, multiplying rational expressions. So let A, B, C, and D be expressions where B and D are not 0 because they're in the denominator. So A over B times C over D equals AC over BD. So simplify AC over BD if possible. In this situation, obviously it's not. And then here's an example. 5x squared over 2xy squared times 6xy cubed over 10y. All right, so what's going to happen here is 5 times 6 is 30. X squared times x is x cubed. There's no y over here, so y cubed times y is just simply y cubed. So 5 times 6 is 30. X squared times x is x cubed. No y times y cubed, or 1 times y cubed is y cubed. Okay, so then I go down to the denominator. And our coefficients are 10 times 2, or 2 times 10, which is 20. And then I have an x, no x, so I just get an x. And finally, y squared times y is y cubed. So we have 30x cubed y cubed over 20xy cubed. Okay, so they're making it a little bit more difficult, I think, here. So let me get my pen. So then they took 30 and said, well, that's 10 times 3, and 20 is 10 times 2. And then they canceled the 10s. That's fine. But you can also just cancel these zeros. 30 over 20 reduces to 3 halves. All right. And then x cubed over x, and they're breaking it down, x times x squared over x, and then the x's cancel. But remember the rule, x cubed divided by x is x cubed minus 1, because this is a 1, and you subtract your exponents, which would give us x squared. Okay, so they're combining all these, and then they're breaking them down. And then y cubed over y cubed just cancels. So this simplified to 3x squared over 2. X cannot equal 0. Y cannot equal 0 because they were in the denominator. Okay, so that's how you simplify that. But I would rather, I just do this here. I don't break them back down after I put them together. Just do the division is subtraction of the exponents. And then you get 3x squared over 2, where x can't be 0 and y cannot be 0. Okay, example 2 is multiplying rational expressions. So we have a product, 8x cubed times y over 2xy squared times 7x to the 4th y cubed divided by 4y. All right, so the first thing I'm going to do is focus on the numerator. And you see this 8 times 7. So that's going to be 56. X cubed times x to the 4th is x to the 3 plus 4, which is x to the 7. And y times y cubed is y to the 1 plus 3, which is y to the 4th. I'm going to divide that by, and then I do the same in the denominator. Okay, I have a 2 times 4 is going to give me 8. Okay, and then I have an x, no x. So I'm just going to write x. Then I have a y squared. And I have a y to the fourth, or a y to the one. So y to the 2 plus 1 is y cubed. Okay, so we've simplified this into one fraction, but then we have to break it down. 56 is 7 times 8. And I have an x down here, so I don't know if I want to do it that way. I don't think I do. The book shows it all broken down, but I'm just going to do this. 56 divided by 8 is, 56 divided by 8 is 7. X to the 7 divided by x to the 1 is x to the 7 minus 1, which is x to the 6th. Y to the 4th divided by y cubed is y to the 4 minus 3, which is y to the 1, or simply y. So my answer to this problem is 7x to the 6th y. But since this simplified to this, I also have to say x cannot equal 0, comma, y cannot equal 0. So this is our complete answer. You also want to include your restriction on your domain. Okay, so now you should be able to do problem number 4 in your exercises. Okay, example 3 is multiplying rational expressions, and they want us to find the product of this mess, but it's really not that bad, okay? So the first thing you want to do is just focus on one component. There are 4. There's the numerator, there's a denominator here, there's a numerator here, and there's a denominator here. So I'm just going to focus on those, and I'll use the colors that you see. I can't use yellow or you won't be able to see it. So I'll use, I don't know, I'll use red. So how about I highlight that red? There. So I'll use red here. So I'll do it down here. 3x minus 3x squared. I can factor out a 3. There's a 3 here. There's a 3 here. There's an x here. There's an x here. So I can take an x as well. Close the parentheses. Open the parentheses. 3x times 1. When I'm distributing, 3x times 1 is 3x. Minus 3x times x is 3x squared. So I'm simplified this down to 3x times 1 minus x. Okay, that wasn't bad. And then I'm going to go to the next one. X squared plus 4x minus 5. And I'm going to put my parentheses. X times x is going to give me this x squared. I want factors of 5, and it's prime, so it's obviously going to be 5 times 1. And they have to add up to 4, so 5 is positive and 1 is negative. So 5 minus 1 is 4. 5 times negative 1 is negative 5. And so I will write that here. X plus 5, x minus 1. Okay, then multiply. Draw another fraction here. Switch to blue for this. X squared plus x minus 20 is, 2 parentheses, x in the first term. Signs are different, plus minus. Factors of 20 that add up to 1, 5 times 4. So I'm going to put x plus 5, x minus 4. Okay, see, this isn't so bad. And then finally, 3x does not simplify, so I put it there. So there are the 4 numerators and denominators factored. Now, let's take a break here for a second because we now have to cancel things, but we have an issue right here. All right, a 1 minus x and an x minus 1 are really close. They're just a factor of -1. So off to the side over here, I'll do this over here. 1 minus x. If I have 1 minus x, okay, think of that, factor out or multiply those by -1. 1 times -1 is going to be -1, right? -1 times a -1 is +1. And in order to get a negative here, it's a negative times a positive. So if I distribute, Negative times a negative is positive. 1 times 1 is 1. Distribute. Negative times a positive is negative. 1 times x is x. So now I have this, but I can rewrite that with the x first. Positive x minus 1. So as you can see, I have an x minus 1 here. So I'm going to change this right here to, I'm going to put a parentheses, I'm going to put x minus 1, and then times a negative 1 like this. Okay, hopefully that makes sense to you. Whenever they're reversed like that, okay, I'm going to leave that there. Whenever they're reversed like that, you can change it. Actually, I don't need that anymore. Okay, and now I have those. So now we're going to do some canceling because anything divided by itself is 1. So 3x divided by 3x is 1. And when you multiply by 1, it's a multiplicative identity. You get that same thing that you're multiplying by. All right, I have an x minus 1. I have an x minus 1. I have an x plus 5. I have an x plus 5. Look at all the stuff that canceled. Okay, so now I have a negative 1 times x minus 4, and this is going to simplify. If I multiply this now, it's going to be negative x, and then a negative times a negative is positive. So I ended up with negative x plus 4, but don't forget, x can't be anything in the denominator that makes any of the factors 0. So x cannot equal 0 right here. X cannot equal 1 because 1 minus 1 is 0. And x cannot equal negative 5. Okay, so our solution to this is whoops. Here, I don't want my fill. How do I do that? More. Fill. Undo that. I'm just going to undo that. Oh, quit yelling at me. Okay, Control C. I just want a box around my answer. Let's just leave it at that. Okay, so it's negative x plus 4. X can't be 0, x can't be 1, and x cannot be negative 5. Now you can put those in order, negative 5, then 0, then 1. And either way, as long as you're listing them, you don't restricting your domains, it's all good. So that is how you simplify or multiply rational expressions. It's nice to be able to do problem numbers 14, 16, and 18 in the exercises. Okay, example 4 is multiplying a rational expression by a polynomial. It's really not much different than what we've been doing. So I'm going to rewrite this, x plus 2 over, and I might as well factor this as I'm going. This is a difference of cubes. Okay, do you remember how to do that? You take the sign with this cubed root minus the cubed root, okay? And then it's going to be x squared plus 3x plus 9. Okay, so if you don't remember, it's this cube root of the first term, keep the sign, cube root of the second term. So really it's a minus b, a squared plus ab plus b squared. Okay, anyway, we get that. And then I'm going to just extend that and then multiply by, and this is x squared plus 3x plus 9. And think of that as over 1. Okay. So as you can see, the quadratics are the same. There's no need to factor these and look for factors of 9 that add up to 3 because you're not going to find any. So rather than factoring this or trying to factor it, if your quadratics are equivalent, then the whole thing's just simply cancel. X squared plus 3x plus 9 cancels with x squared plus 3x plus 9. And we're left with x plus 2 divided by x minus 3. Don't forget your restriction on your domain. X can equal 3, but X can also not equal what this when this is equal to 0. Okay. The book isn't saying that. So how do we find our restriction on our domain here? Oh, it's cubed. Never mind. No, it does matter. X cannot equal 3 because 3 times 3 is 9 times 3 is 27. 27 minus 27 is 0. Actually, that's the only restriction because this was not in the denominator. Okay, so there it is. X plus 2 over X minus 3, where X cannot equal 3. Now you should be able to do problem number 20 in your exercises. Okay, let me explain this a little bit more right here. See this x squared plus 3x plus 9? Well, if I factor that and that has factors that can equal 0, then I cannot have that as a domain. So I want to show you this as graphed. So I went to Desmos and put this in my calculator, x squared plus 3x plus 9. And as you can see, it does not have any real solutions. There are no zeros. It never crosses the x-axis. Okay, so you don't have to worry about any zeros because there aren't any real ones. Okay, so that's why I don't have to restrict the domain on any other real zeros other than 3. Okay, so now I'm done. Okay, another core concept. Let A, B, C, and D be expressions with B not equal to 0, C not equal to 0, and D not equal to 0. Property says that A over B divided by, so this is a new property. Okay, there's a division symbol right there. A over B divided by C over D equals A over B times, and we're taking the reciprocal of the second. Okay, so you flip it and you switch it. Switch from division to multiplication and flip what you're dividing by. Okay, and then you simplify AD over BC if it's possible. So here's an example. 7 over x plus 1 divided by x plus 2 over 2x minus 3 equals 7 over x plus 1 did not change. The division changed, but the x plus 2 over 2x minus 3 became 2x minus 3 over x plus 2. And then you combine them like so. I haven't been doing this, but whenever there's a times, all you got to do is extend the division symbol and put everything together as multiplication. And you get 7 times 2x minus 3 over x plus 1 times x plus 2. And x cannot equal 3 halves. Okay, x can equal -1, x can equal -2. X cannot equal 3 halves. Why are they only saying 3 halves? That's interesting. So this x cannot equal 3 halves came from here. You put 3 halves in there, you get 0. But what about -1 and -2? Anyway, don't forget all of your domain restrictions. Okay, example 5 is dividing rational expressions. So in this situation, there's only one change, and that is that right there. Okay, we've been doing multiplication the whole time. Here's what's going to happen. You take 7x over 2x minus 10. That did not change. You switch the division symbol to multiplication. You take the denominator and make it the numerator. You take the numerator and make it the denominator. Okay, so all you do is switch it from division to multiplication and take the reciprocal. Flip it and switch it. All right, so now we're going to be just doing problems we've already done. So 7x can't be simplified. I can factor a 2 out here, leaving me with x minus 5 times, and I'm going to factor the numerator, or the numerator, x and x, factors of 30 that add up to 11, and they're the same sign, and they're both negative. Well, 6 times 5 is 30, 6 plus 5 is 11, so there it is. And then I can factor out an x from this, so x times x minus 6. Okay, So now that I've done that, x minus 6, x minus 6. I have an x minus 5 over here, and I have an x minus 5 over here. I have an x here, I have an x here, and this simplified to 7 over 2. Okay, but what are the restrictions on our domain? X can't equal 5, and x cannot equal 6. Okay, and oh, by the way, there's an x right here all by itself. X can also not equal 0. Okay, so x can't equal 5, x can't equal 0, x can't equal 6. So there is dividing. It's just one simple step, flip it and switch it, and then you're doing what we've been doing. So now you should be able to do problem numbers 28 and 30 in your exercises. Okay, here's example 6, dividing a rational expression by a polynomial. So we have this divided by this. So what do we do first? Switch it to multiplication. So I want to get rid of that right there. And while I'm doing this, I guess I could factor this as well. So I have 6x squared plus x minus 15. So let me just highlight this again. So keep in mind, let me switch that to red. We have a numerator. We have a denominator. And we have this. So there's three things we have to factor. So let me factor this first. So 6x squared plus x minus 15. So always check, see if there's a GCF, greatest common factor, and there is not. Can't factor anything out of this. So then what I do, it's different than what the book shows, but I like to take A and multiply it by C. And I get x squared plus x minus, and 6 times 5 is 30, carry the 3, so that's 90. So now I have x squared plus x minus 90, and I can factor that. So when I do that, I get an x here and an x here. Signs are different, plus, minus, and I need a difference of, or sideways minus, plus, minus. I need a difference of 1, factors of 90. Well, that's 10 times 9, and I want the bigger one positive. So 10 and 9. 10 times 9 is 90. 10 minus 9 is 1. Okay, but I multiplied by 6, so now I've got to divide by 6. I find this the easiest way to factor these, and then simplify, reduce x plus 5 over 3, and x minus, and that's 3 halves. And since they're not since they're not integers, the denominator goes out in front like so, and I get 3x plus 5 times 2x minus 3. So if I FOIL that, 3 times 2 is 6x squared, outers minus 9x, inners plus 10x, which gives me x, and 5 times 3 is negative 15. So here is this factored. So that's going to become, I'll do it over here. That is going to be 3x plus 5 times 2x minus 3 over, and then 4x squared, I can't do anything with that. So I'm just going to leave that 4x squared. And then I'm going to multiply. And then I'm going to take this 3x squared plus 5x and factor it. 3x squared plus 5x. Well, it's two terms with an x in each, so I can factor out an x, and that will leave me with 3x plus 5 times x. So since this is division of that, that's the same as multiplying 1 over this. So it's going to be x times 3x plus 5. Okay, so, and then remember this multiplication, all we really need to do is combine these. And so this would simplify to, I haven't been doing this, but let's do it. 3x plus 5 times 2x minus 3 times 1 is not necessary to write. I'm going to write the 3x plus 5 first, so they line up. 3x plus 5. I also have a 4x squared and an x. Okay, so I can write it like that. Okay, so the 3x plus 5s cancel. 3x plus 5s cancel, leaving me with 2x minus 3 over 4x cubed. Okay, so now I wanted to get the graphing calculator up because I wanted to show you something. So our answer is 2x minus 3 over 4x cubed. Okay, but there's a restriction on our domain. We have a vertical asymptote. I graphed this as the original. I put this in the calculator. So you can't see it all. Actually, you can when I hit graph. It's right up here. Second, calculate a value. And I put -5 divided by 3 in. And whoops, what am I doing? Clear. Second, calculate value. -5 divide 3, enter. So here's my original function. 6x squared plus x minus 15 divided by 4x squared, all divided by, it's cut off, but it's 3x squared plus 5x. And it's a hyperbola, like so. And when I checked -5/3, y has no value. And the reason for that is once I flipped this and multiplied by x and 3x plus 5, what makes this 0? Well, if I take 3x plus 5 equals 0 and subtract 5 from both sides, I get 3x equals -5. Divide by 3, and I get x equals -5/3. So x cannot equal -5 over 3. So because if I plug that in, it's right here, but there's a hole in my function. It goes there and then it jumps over -5/3. There is no y value. Okay, there's a vertical asymptote at 0 because of this right here. So x can also not equal 0. Okay, and that's also in the original. So x can't equal -5/3 and x can't equal 0. And the answer is 2x minus 3 over 4x cubed. Okay, so now you should be able to do problem numbers 32 and 34 in your exercises. Okay, here's example 7, solving a real life problem. It says the total annual amount I in millions of dollars of a personal income earned in Alabama and its annual population P in millions can be modeled by, okay, annual amount of I personal income equals 6,922 times T plus 106,947, all divided by 0.0063 T plus 1. And P equals 0.0343 T plus 4.432. Okay, where T represents the year, with T equal 1 corresponding to 2001. Okay, so years since 2000 is what that means. So this year is 2023, so T would be 23. It says find a model M for the annual per capita income. Per capita means per person. Estimate the per capita income in 2010 and assume that T is greater than 0. So T can't be negative. All right, so what are we going to do? Well, the first thing you do is you have to find a model M for the annual per capita income and divide the total amount I by the population P. So all we're doing is taking I and dividing it by P. So M equals I divided by P. Okay, so you write I divided by P. They didn't do that, but they could have written first M equals I divided by P. That's all we're doing. This divided by this. Okay, so it's just like what we've been doing. What we're going to end up doing is switching this division symbol to multiplication and putting 1 over this. All right, so then we're going to continue. And there it is. This stayed the same times the reciprocal of this. Okay, so we've done that in prior examples. And when we do that, we get this here. So we get 6,922 T plus this. That's our numerator. Times 1 is just that. And then it's this times this, which is right here. Okay, to estimate Alabama's per capita income in 2010, it says to let T equal 10 in the model. So we don't want to simplify this or anything. We just leave it as is, and then we just plug in T equals 10 into that model. And it's going to look like this. 6922, here's a T, so put a 10, plus 106,947, divided by 0.0063, here's a T, so we put a 10, and times 0.0343, here's a T, so we put a 10. And so all we're doing there is substituting in 10 for all the T's. And when we do that, plugging that into our calculator, we should have gotten 34,707, which means that in 2010, the per capita income in Alabama was approximately 34,707. Okay, so I'm going to take this one step further and open my calculator up, clear it, and I'm going to see what the per capita income is now. So in other words, all I have to do is put this into my calculator. So I'm going to put a parenthesis for the numerator. 6922 times, and this is 2023, so that's 23 years since 2000, so you put that, plus 106,947, close the parentheses, divide, and I'm going to put these in parentheses, so I have to have double parentheses here for the denominator. So there's the parentheses for the whole bottom. There's parentheses for 0.0063. So it's 0.0063 times 23 plus 1. Close those parentheses, open new ones, 0.0343 times 23 plus 4.432, close parentheses, close the denominator parentheses, hit enter. There it is. So in 2010, the per capita income was 34,700. And now that it's 2023, the per capita income is now $44,526.49, give or take. Okay, so that's how you use formulas in the real world, real life situation, and we found a value for per capita income. Now you should be able to do problem number 37 in your exercises. Okay, so that brings us to the end of chapter 7.3. Here are the problems that you need to do in your exercises. Thanks for watching and have a great day.